Swayam Prabha. Digital India. Educated India.
Good morning. So, in the previous module, we looked at two different models of sequential competition. One was the Stackelberg model, where firms were choosing quantities. Firm 1 moved first, which was the leader. Firm 2 observed firm 1's choice of output Q1 and then chose the Q2. And we solved the model and we learnt that here firm 1, which is the first mover, which is the leader, has the first mover advantage. The profit of firm 1 was strictly larger than the profit of firm 2. Then we looked at the sequential move game, but now the firms were choosing prices. Now, when goods are homogeneous, when goods are identical, sequential price competition gives the same outcome as the Bartra model, where the firms simultaneously choose the price. We then introduced product differentiation in this model, where firm 1 moved first, chose a P1, firm 2 observed the P1 and then chose a P2. And we figured out that in this model, in sequential price competition with product differentiation, it turns out that firm 2, which is the follower, has the second mover advantage, right. So, in the sequential move games, depending on what the particular nature of competition is, whether it is quantities or prices, whether you have identical products or whether you have product differentiation, we can have first mover advantage or the second mover advantage. Now, we want to move to a new topic, but we want to use the ideas that we have developed in the Stackelberg model. And the topic of today's lecture is going to be entry deterrence. So, we want to use the Stackelberg model to understand what we mean by entry deterrence. There are two models that we will talk about in entry deterrence. So, let us start with our basic model. So, we can use the Stackelberg model. So, we can use the Stackelberg model to understand entry deterrence. Now, the idea is that firm 1 is the first mover or the leader, and firm 1 can strategically choose its output, let us call it Q1 or rather Q bar, so as to deter firm 2, the potential entrant, from entering the market. Now, in the analysis of entry deterrence, we will analogously use firm 1 as the incumbent and firm 2 as the entrant, right. So, we will use the incumbent as the leader or firm 1, and we will call the entrant to be firm 2, right. So, sometimes we might just use the notation I, sometimes we might just use the notation E, depending on what the context is, right. So, the incumbent which is who is the Stackelberg leader, chooses the output first. So, the incumbent, which is the Stackelberg leader, chooses the output first. Now, there are two assumptions that we are going to impose. The first one is a strong and restrictive assumption, which says that when the incumbent chooses this output, whatever be that output, the entrant is going to believe that once it enters, the incumbent is no longer going to alter that output, right. So, there are two assumptions that we are going to impose. The first assumption is whatever is the output chosen by the incumbent, the entrant believes that this output will not be changed, will not change even if E were to enter the market. So, this is a very strong and restrictive assumption. We will relax this later on. In fact, that is going to be one of the critiques of this first model that we are going to develop, and then we will see what happens when we introduce a two-stage game and look at post-entry competition between the incumbent and the entrant, right. For the moment, let us stay with this assumption that whatever is the output chosen by the incumbent, the entrant believes that post-entry the incumbent is not going to change the output. The second assumption that we are going to impose is that the entrant's average cost is declining, right. So, the entrant's average cost is declining over the initial levels of output. Okay. So, let us incorporate these in a graph. Okay. So, let us say, so we have output and we have the price. Okay. So, let us say our market demand curve is given by this curve. So, let us call this to be T of P. So, this is the market demand. Now, suppose the incumbent is choosing an output Q bar. So, let us say the incumbent I commits to producing Q bar units, right. So, let us say that Q bar is somewhere here, right. So, the incumbent commits to producing Q bar units, right. So, in other words, if there was just one firm in the market, Q bar units would be produced by the incumbent and the price would be, let us say, P bar, right. So, the outcome in this market would have been an output of Q bar and a price of P bar. Now, the assumption 1 says that whatever is the output chosen by the incumbent. So, here the output chosen by the incumbent is Q bar. The entrant believes that this Q bar will not change. So, in other words, the incumbent is committing to producing Q bar units. The residual demand for the entrant is essentially the market demand less the Q bar units that the incumbent has already sold, right. So, this residual demand, so let us say, so the entire demand curve shifts down by an amount Q bar. So, let us say the residual demand curve is given by this. So, let us call this to be RE, residual demand for the entrant, right. Now, the entrant is going to take this residual demand curve as given, asks what its marginal revenue curve is. So, let us say the entrant's marginal revenue curve is given by this equation. So, the entrant's marginal revenue is this, right. So, this is the entrant's marginal revenue. Let us suppose that the marginal cost curve is somewhat like this. So, this is the marginal cost curve of the entrant. Now, profit maximization implies that the entrant compares the marginal revenue with its marginal cost and chooses to produce an output which is given by, let us say, QE, right. So, the output is QE. Now, given that the incumbent has produced Q bar units, the combined output is QE plus Q bar, which let us say leads to a price. So, if I add that, it leads to a price which is, so QE plus Q bar, which let us say is some P naught, right, or P 0, right. So, this is the price that is obtained, and suppose this price P 0 is such that, suppose the price P 0 is such that it just barely covers the entrant's average cost curve. So, in other words, the entrant's average cost, let us say, is something like this. So, this is the entrant's average cost curve, right. So, at this output Q bar, right, at this output Q bar, the PE, or rather the P naught that turns out, is equal to the average cost that the entrant incurs of producing QE units. So, the price that is the price that eventually arises in this market is barely covering the entrant's average cost. So, by committing by committing to q bar, the incumbent removes any profit incentive for the entrant, right. So, by producing q bar units, so I have produced the q bar units, which leads to a residual demand curve Re for the entrant. Based on this residual demand, we calculate the marginal revenue curve for the entrant. The entrant chooses its profit maximizing output based on marginal revenue equals marginal cost. It turns out that the output QE is such that it leads to a price P0, which barely covers the average cost of the entrant. So, the entrant's profit is 0, the entrant has no incentive to enter. So, no incentive to enter the market. Now, while this model is simple, the major drawback that it has is the very restrictive assumption that we had imposed, right. So, it is saying that, so the model is a little bit ad hoc, right. So, the model, let us make a note. So, the model is a little bit ad hoc, The reason it is ad hoc is because it says that the incumbent's output remains at q bar because it is costly for it to change, for I to change it. It is costly for I to change, right, change the output, right. Now, to have a richer model, we need to specify what happens, we need to relax this assumption and essentially look at what happens to the post entry game between the entrant and the incumbent. So, to get a richer model, we need to relax the first assumption and explicitly model the post entry competition between the incumbent and the entrant, right. This is going to be our next task, right. So, while this model is essentially giving us a flavor of entry deterrence in the sense that by choosing or by committing to an output which is q bar, the incumbent can remove the incentive for the entrant to enter the market. The problem is that we have not yet modeled the post entry competition between the incumbent and the entrant. In other words, we are not justifying that the incumbent would not change its output when there is entry, right. So, let us see a model where there is post entry competition between the incumbent and the entrant. Okay. So, we will consider a two-stage game. Now, in the first stage, so in stage 1, the incumbent is going to move and chooses a capacity level. Think of the capacity level as the size of the plant that the incumbent wants to build. So, in stage 1, incumbent moves and chooses a capacity level, call that to be, let us say, K1 bar. So, this is the level of capacity that the incumbent chooses at a cost of R K1 bar. R is the per unit capital cost. So, R K1 bar is the fixed cost of capacity, right. So, R is the per unit cost of capital, per unit cost of capacity or capital. Now, so notice that by choosing a capacity K1 bar, the incumbent in stage 2 can choose to produce an output which is less than the capacity, in which case there is going to be some unused capacity. It can produce an output which is exactly equal to K1 bar, which is exactly using its entire capacity, or it can choose to produce an output Q1 which is larger than the capacity, in which case it needs to add on to its capacity by building more capacity in stage 2. Essentially, once the K1 bar is chosen by the incumbent, in stage 2 it can't reduce the capacity, right. So, it can add to the capacity, but it cannot reduce capacity. In other words, the firm 1 cannot sell some of its unused capacity in stage 2. So, let us make a note. So, while capacity of firm 1 can be increased, it cannot be decreased. In other words, firm 1 cannot sell its unused capacity. The entrant observes, the potential entrant observes K1 bar and then decides. So, the potential entrant observes the K1 bar and then decides to enter or stay out. If it enters, the post entry competition is Cournot, right. So, if there is entry, then the stage 2 competition is Cournot. Notice that unlike the incumbent, the entrant is not there in stage 1, right. So, it is not there in stage 1. So, when the entrant decides to enter in stage 2, it needs to choose both its capacity K2 as well as what quantity it wants to produce. As far as firm 1 or the incumbent is concerned, it has already chosen the capacity K1 bar in stage 1. So, it chooses a Q1 or Qi in stage 2, and if it wants to add to capacity, it needs also to choose the amount of capacity that it wants to add in stage 2. So, the two firms simultaneously choose Q1 and Q2 and also capacity K1 and K2 in stage 2. For the incumbent, the capacity is constrained. Because in stage 2 the capacity cannot be less than K1 bar. Cannot be less than K1 bar. And we have mentioned that the incumbent can increase capacity, but it cannot reduce it. Let us also assume that every unit of output requires 1 unit of labor and 1 unit of capital. Right. So, labor L and 1 unit of capital, which is K. The cost per unit of labor is given by W, and R as before is the cost per unit of capital. We have already mentioned this earlier. So, let us write down the cost functions for the two firms. So, firm 1's cost is going to depend on what output it is going to produce in stage 2. Well, its cost is going to be W times Q1 plus R times K1 bar if Q1 is less than equal to K1 bar, right. So, if it chooses an output which is less than its capacity that it has built in stage 1, then its cost is going to be W times Q1 plus R K1 bar. whereas if it wants to produce more than its capacity, then it needs to add to the capacity. So, that is going to be W plus R times Q1 when Q1 is greater than K1 bar. This essentially means that the marginal cost of firm 1 is going to be W as long as Q1 is less than equal to K1 bar, and the marginal cost is equal to W plus R for Q1 which is greater than Q1 bar. Similarly, if I look at firm 2, firm 2's cost is simply going to be W plus R times Q2 plus some fixed cost that it incurs, let us call it as F. So, firm 2's marginal cost is essentially going to be W plus R for any level of output that it wants to produce. Now, if I were to graph this, so if I look at firm 1's marginal cost and firm 2's marginal cost, let us call it in rupees per unit. So, let us say the K1 bar was somewhere here, K1 bar was somewhere here. So, as long as my Q1 is less than equal to K1 bar, the marginal cost for firm 1 is W, right. So, this is the marginal cost for firm 1. So, for any output larger than K1 bar, firm 1's marginal cost essentially is W plus R, is W plus R. So, this is firm 1's marginal cost, whereas for firm 2, the marginal cost always is W plus R for any level of output. So, firm 2's marginal cost is W plus R. So, this is firm 2's marginal cost, right. So, this graph essentially explains why investment in capacity can have a commitment value, right. So, investment in capacity can have a commitment value, right. So, I's commitment to produce at least as much as K1 bar. So, I's commitment to produce at least K1 bar, right. So, at least K1 bar, and for all these units its marginal cost is only W, which is smaller than the marginal cost of the entrant. So, I's commitment to produce at least K1 bar is believable, is made believable by the fact that for Q1 less than equal to K1 bar, its marginal cost is lower than that of firm of the entrant, right. So, its margin. So, the fact that the incumbent is investing in that capacity, right, and this and the fact that it is committed to investing in this amount of capacity K1 bar is made believable by the fact that for all these outputs Q1 which is less than K1 bar, its marginal cost is W, which is lower than W plus R. So, that is a very important takeaway from this graph. Okay. So, let us move on. Now, so since this is a two-stage game, we will solve the model backwards. So, we will start with stage 2, which is the Cournot competition stage, and then we will ask for what are the optimal choices of outputs chosen by the firms given a capacity K1 bar that is chosen by the incumbent in stage 1. Then we will go back to stage 1 and then we will ask what is the optimal choice of capacity, right. So, we begin with stage 2, and solve for the quantities given the capacity, given the choice of capacity in stage 1. We will then determine the optimal choice of capacity in stage 1 that maximizes I's profit in stage 2, right. So, this is the standard way in which we solve the leader fall in any sequential game. So, we start with the end of the game, which is stage 2, solve for the quantities because stage 2 is the Cournot competition stage. So, given the capacity chosen by the incumbent, we solve for the Cournot outcomes, and then we step back to stage 1 and then ask what is the choice of K1 bar that maximizes the incumbent's profit. Now, so let us write down the incumbent's profit, right. So, the incumbent's profit is the total revenue minus the total cost, which is essentially the price times quantity, right. So, the goods are identical. So, we will treat the inverse demand curve to be P equals A minus B times Q1 plus Q2. So, Q1 plus Q2. So, we will use I and 1 analogously, 2 and E analogously, right. So, that is going to be the price times quantity. So, that is A minus B times Q1 plus Q2 times Q1 minus the total cost. Now, recall the total cost can either be W Q1 plus R K1 bar if Q1 is less than equal to K1 bar, or it can be W plus R times Q1. So, the total cost is either W Q1 minus R K1 bar for Q1 less than equal to K1 bar, or the profit is going to be A minus B times Q1 plus Q2 times Q1 minus W plus R times Q1 when Q1 is greater than Q1 bar, because notice that is what the cost is when the output is greater than K1 bar. Now, if you look at the total revenue function, in both cases, the total revenue leads to a marginal revenue for the incumbent, which is, so essentially if I take the marginal revenue, so this is A times Q1 minus B Q1 square minus B Q1 Q2. So, that is going to give me an A minus B Q1 square is going to give me minus 2 B Q1 minus Q1 B Q1 Q2 is essentially going to give me a minus B times Q2. So, this is the marginal cost of the incumbent. Now, the incumbent is going to set its marginal revenue to equal the marginal cost. Now, this marginal cost, so this marginal cost will be set equal to either W or to W plus R. These are the marginal costs of the incumbent, right, depending on whether the Q1 is less than equal to K1 bar or is greater than K1. Well, if I were to do that, so if I set the marginal revenue, which is A minus 2 B Q1 minus B Q2 to equal, let us say, the marginal cost, which is equal to W, we will find out the best response function for firm 1 for each choice of Q2 in stage 2. So, this will give us a Q1 star. So essentially A minus 2 B Q1 minus B Q2 equals W is going to give me Q1 star as a function of Q2, which is equal to A minus W by 2B minus Q2 divided by 2. This is for Q1 less than equal to K1 bar, right, and we will have, so similarly setting 2B Q1 minus B Q2 equals W plus R will give us the best response function of firm 1, which is A minus W minus R divided by 2B minus Q2 by 2 for Q1 greater than K1 bar, right. So, this is the best response function for firm 1. This is the best response function for firm 1. So, in other words, there is going to be a jump in the best response function for firm 1 at K1 bar, right. So, for Q1 less than K1 bar, it takes one particular form, and for Q1 greater than K1 bar, it takes the other form. So, there is going to be a distinct jump at this K1 bar. So, let us so before we draw, so let us first draw it and see what it looks like. So, if I were to draw the best response function of firm 1, so this is Q1, this is Q2, and let us say I have a K1 which is here, a K1 bar which is here. Now, to the left of K1 bar, the best response function is A minus W divided by 2B minus Q2 by 0. So, when Q2 is 0, right. So, when the entrant does not produce anything, the incumbent is producing the monopoly output A minus W divided by 2B. So, that is A minus W divided by 2B, A minus W divided by 2B, and sorry. So, this is when Q2 is 0. Okay, so, this is Q2 is equal to 0, the incumbent's choice is A minus W divided by 2B. So, let us graph it here. So, that is A minus W divided by 2B, right. And when the entrant is producing A minus W by B, the entrant's choice is going to be 0. So, let us sorry about that. So, let us call this to be this is Q2. So, let us say this is A minus W divided by B. So, essentially this would have been the best response function for firm 1, right. Now, for Q1 which is greater than K1 bar, this is the second best response function is what we need to work with. So, now notice if Q2 is 0, the incumbent's output is the monopoly output which is given by A minus W minus R divided by 2B. So, that is going to be somewhere here. So, that is going to be A minus B. So, this point is going to be A minus B, A minus W minus R divided by 2B, and when Q2 is equal to A minus W minus R divided by B, Q1 star is going to be equal to 0. So, I have a point here. Notice I am going to get a parallel line. So, this is essentially A minus W minus R divided by B, right. So, A minus W minus R divided by B. So, essentially our best response function for firm 1 is going to be this part for Q1 less than K1, right. So, this is going to be the best response function, and for Q1 greater than K1, the best response function takes this particular form, this particular best response function, and then we will just, so K1 bar is the point of kink. So, this is the best response function for firm 1 as a function of Q2, right. So, on the other hand, as far as firm 2 is concerned, for firm 2 the marginal there is just one marginal cost which is W plus R. So, as far as firm 2 is concerned, so pi 2 is again total revenue minus total cost, which is the price A minus B times Q1 plus Q2 times Q2 minus the margin minus the total cost, which is W plus R times Q2. So, essentially the marginal revenue for the entrant or firm 2, right. So, the marginal revenue for the entrant is going to be, so this is going to be A Q2 minus B Q1 Q2 minus B Q2 square. So, we are going to have A minus B Q1 minus 2B Q2, and its marginal cost we have already seen is W plus R. So, firm 2's best response function or the entrant's best response function Q2 as a function of Q1 is essentially A minus W minus R. If I set the marginal revenue to equal the marginal cost, we will get A minus W minus R by 2B minus Q1 divided by 2. So, when Q1 is equal to 0, Q2 is going to be A minus W minus R divided by 2B. So, we are going to get a Q2 here, and when Q1 is A minus W minus R divided by B, Q2 is going to be equal to 0. Okay, so, we will graph firm 2's best response function in just a moment, right. So, essentially what we have now characterized is the stage 2 solution, wherein the stage 2 outcome rather, wherein the two best response functions are characterized. Okay, so where the Cournot equilibrium will be will depend on the particular will depend on where K1 bar is, where the kink occurs. So, there are three cases that we need to draw, right. So, the first case is the following. So, we will determine, so we are now in a position, so let us first write. So, we want to determine the Nash equilibrium in quantities in stage 2, and there are three possibilities. The first possibility is the following. So, So, let us draw Q1 and Q2. So, we have Q1 and Q2, the incumbent's output and the entrance output, and I am going to reproduce the best response function for firm 2. So, the best or rather the best response function for the incumbent, right. So, this is the one where its marginal cost is essentially W. This is the one where its marginal cost is going to be W plus R, right. So, in the first case we will take the kink and we are going to have firm 2's best response function, which is A minus W minus R divided by 2B minus Q1 by 2. So, when Q1 is 0, essentially this is A minus W minus R divided by 2B, and when Q1 is equal to A minus W minus R by B, Q2 is essentially going to be equal to 0. So, this is let us say A minus W minus R divided by B. Now, let us call this point to be point T, let us call this point to be point V. Now, in the first case we will say that the kink in firm 1's best response function, So, the kink in firm 1's best response function is to the left of T, So, in other words, if I were to draw firm 1's best response function, so we have the kink, so the kink is going to be somewhere here and this is what it takes, right. So, we have the K1 bar which is here, right. So, the kink in the best response function is to the left of T. So, the K1 bar is to the left of T. Now, in this case the best response function of firm 1, so this is the best response function of firm 1 and the best response function of firm 2 intersect at T. The equilibrium is the symmetric Cournot equilibrium. So, the equilibrium is the symmetric Cournot equilibrium, right, and this corresponds to a case of capacity expansion, wherein in stage 1 if the incumbent has chosen a capacity which is K1 bar, which is as given in the graph. In stage 2 there is Cournot competition, the best response functions are intersecting at T, but notice the Q1 Cournot that is produced by firm 1 is larger than the K1 bar, which requires the incumbent to expand its capacity in stage 2, right. So, this is one possible depiction of the Cournot outcome in stage 2. Let us look at a second possibility, right. So, the second possibility is, again let us first draw it and then we will characterize it. So, this is Q1, this is Q2. So, let us first get the best response functions for firm 1. These are the best response functions of firm 1 and firm 2's best response function essentially is this, and these points of intersection are T and V. So, in the second case the kink in firm 1's best response function, is to the right of V. So, in other words I have, so if I were to draw firm 1's best response function, so it takes this particular shape. So, it follows all the way till here and let us say the K1 bar is here. So, let us say the K1 bar is here. So, this is the best response function of firm 1 and this is the best response function of firm 2 and my K1 bar essentially is here, right. So, notice unlike the previous case where the kink was to the left of the point T, right. So, this is the point T, the kink was to the left of the point T. Now, I have a case where the kink is actually to the right of the point V, right, and now the equilibrium, the two best response functions intersect at V. So, the equilibrium is the asymmetric Cournot outcome. So, it is asymmetric because firm 1's marginal cost is going to be W, firm 2's marginal cost is going to be W plus R. So, the quantities that we get will not be identical. So, equilibrium is the asymmetric Cournot equilibrium, at V, but now notice that firm 1 in stage K1 has built a lot more capacity than the output that it is producing in stage 2. So, there is excess capacity. So, this corresponds to a case of excess capacity, right. Whereas, in the previous case there was capacity expansion, right. So, I had built a capacity K1 bar in stage 1, but I ended up producing a larger output which is captured at Q1T, whatever was the Cournot output that required me to expand capacity in stage 2. But in the second case the capacity in stage 1 itself was enormous. So, in stage 2 the output that the firm is producing is actually going to be Q1C. We will later on ask whether the firm will ever want, whether it will be optimal for firm 1 to be choosing a K1 bar which is to the right of the point V. That is a separate question. Right now we are just saying, given the choice of capacity in stage 1, what are the Cournot outcomes that we will see in stage 2. Finally, let us look at an intermediate stage wherein the kink in the best response function lies between T and V. So, this is Q1, this is Q2. So, this is the best response function for firm 1. So, the best response function for firm 1, and let us get firm 2's best response function. So, these are T and V, right. So, now the kink in firm 1's best response function is in between T and V. So, in other words think of the K1 bar being such that the best response function for firm 1 is of this particular form, right. So, the kink is somewhere between T and V. So, the kink is somewhere between T and V. So, this is the K1 bar, right. So, now in this case notice that the best response, this is the best response function for firm 1, this is the best response function for firm 2. The two best response functions are going to intersect at some point here, wherein the Q1 will exactly be equal to K1 bar, which means the capacity is fully utilized, right. So, the equilibrium in this case, the equilibrium is on the best response function. The equilibrium is on the best response function, where is on the best response function of firm 2, where Q1 is equal to K1 bar. So, firm 1 will find it profitable to produce still capacity, but will not expand it. So, this corresponds to the case of full capacity utilization. Full capacity utilization. So, let us just briefly recap. So, in one case the kink is to the left of T, I have capacity expansion. In one case the kink is to the right of V, so we have excess capacity, and in the third case the kink is in between T and V, so we have full capacity utilization, right. So, in other words, if we were to capture all of these three things in the same setting, we would have a scenario wherein the outcome in stage 2, the Cournot outcome in stage 2 will be somewhere between T and V. So, this is firm 1's best response function, and if we have firm 2's best response function, the outcome is either going to be somewhere between T and V, right. So, that if firm 2 enters, the equilibrium must lie. So, when I say equilibrium, the Cournot equilibrium in stage 2 must lie between T and V, right, must lie between T and V. Well, the actual point depends on K1 bar, which, and we had captured when we had characterized three different points of K1 bar where the kink occurs. The actual point depends on K1 bar. The minimum amount, so this also tells us that the minimum amount the minimum Q1 is T1, is the Q1 at T1. So, the minimum output that firm 1 will produce is at T1, and the maximum amount of output that firm 1 will produce is whatever this V1 is, right. So, whatever this output is. Okay. Now, so we figured out what is happening in stage 2, which is the Cournot outcome, which is going to be somewhere between T and V. The exact location will depend on K1 bar, but we have also figured out that the minimum capacity will be, so the minimum output is Q1, which is T1. So, that also tells us that the minimum capacity that firm 1 would want to set is going to be at T1, and the maximum capacity that it wants to set is going to be V1. So, one important inference that we can draw, so one important lesson that we have here is, until now, is that firm 1 or the incumbent, will never choose a capacity, which is less than T1 and which is less than T1 or larger than V1, right. So, a setting where, so because the Nash equilibrium outcome is going to be somewhere between T and V, either I will choose a capacity which is at least at T1 or at most at V1, because these are the two bounds on the quantities that we have. Okay. Now, if let us ask what happens if firm 2 does not enter. So, what happens if E does not enter? Well, if E does not enter, then the incumbent, which is firm 1, is essentially a monopolist, right. Now, when can E decide not to enter? Well, so our outcome is either going to be somewhere between T and V, right. So, when I say outcome, the Cournot outcome is going to be somewhere between T and V. So, the outcome T is the one which is most preferred by the entrant, because as we move further down along the best response function of firm 2, Q2 falls, right, which is not a very nice outcome for the entrant. So, the best possible outcome, so best possible Cournot outcome for the entrant, is at T2, right. So, when I say T2, what I mean is the output which is produced at this particular level. Now, if the fixed cost of firm 2 is such that the profit at T2, which is its best possible outcome, turns out to be negative, then the entrant will not enter, right. So, if the profit of the entrant at its best Cournot outcome, that is T2, is less than 0, right. And why would it be less than 0? Perhaps the fixed costs are so high that even at its best Cournot outcome, firm 2 finds that its profit is going to be negative. Then firm 1 will produce the monopoly output. Firm 1 will be a monopolist, and produce the monopoly outcome. At, so let us call it as M1 and let us depict it, right. So, let us just depict it first. So, if we have Q1 and Q2, so the best response functions of firm 1 and 2, and so this is T, this is V. So, firm 2's profit is such that even at its best possible Cournot outcome, its profit is negative. Then firm 1 essentially is a monopolist and will produce the monopoly output at M1. So, it will also set its capacity such that K1 bar is equal to M1, right. So, So we are now we are now moving back to stage 1, wherein we are asking what is the best choice of capacity for firm 1, right. So, what is the best choice of capacity? What is the optimal choice of K1 bar is what we are interested in asking. Okay. So, we will do it in multiple steps, right. So, now notice that this optimal choice of capacity will depend on what the incumbent believes its action of choosing K1 bar will have on the entrant. In other words, if I choose a capacity K1 bar, so in other words, let us say the incumbent, let us say the fixed cost F for the entrant was such that even at its best possible output T2, its profit turned out to be negative, then the incumbent is essentially a monopolist and will simply choose a level of capital which is equal to K1 bar. So, in other words, it will simply set K1 bar equal to M1 and the output chosen by the incumbent in stage 2 is simply going to be the monopoly outcome. Okay. So, the other point that is important to note is that M1 is not just the monopoly output, but is also the output chosen by a Stackelberg leader. And notice firm 1 is the leader in this model, firm 1 moves first. So, the Stackelberg output, we have seen in the last lecture that the Stackelberg output A minus C by 2B, where the marginal cost was C, the inverse demand curve was P equals to A minus B Q1 plus Q2, was exactly equal to the monopoly output. So, this M1 is not just the monopoly output, in our case it is A minus W minus R divided by 2B, is not just the monopoly output, it is also the output which is chosen by the Stackelberg leader. So, I will mention an S point here to denote that Q1S is exactly equal to Q1M, which in our case is A minus W minus R divided by 2B. So, that is an important part. Now, if entry does not occur, then the incumbent essentially is a monopolist and chooses the monopoly outcome at M1. If entry did occur, right. So, if entry did occur, which means the fixed cost is not substantially high, so that the entrant finds it profitable to enter the market. Notice that the incumbent can still exploit its first mover advantage and guarantee itself the Stackelberg leader output, right. So, if the entrant were to still enter, the incumbent can guarantee itself the Stackelberg leader of output. The Stackelberg leader output is the monopoly output Q1M. So, if we put together these 2 points, one when E does not enter and the second when E enters and the incumbent strategically decides to produce the Stackelberg level of output, we can infer that the incumbent would never choose a capacity less than M1, right. So, why is that important? Because we had mentioned a lesson earlier saying that the incumbent will never choose a capacity less than T1 rather, and a capacity larger than V1. We have shortened that space and we are making now a stronger statement by saying that no matter what, either the incumbent is guaranteed the monopoly output if the entrant does not enter, in which case it will choose to produce Q1 equal to the quantity that it produces at M1, which will then imply that it sets a capacity K1 bar equal to the capacity here, or it could or if the entrant were to enter, it could always exploit its first mover advantage and choose to produce the Stackelberg level of output. The Stackelberg level of output is nothing but the monopoly output. Again, I will produce Q1S which is equal to Q1M and set up a capacity K1 bar which is exactly equal to the capacity at M1. So, this tells us that if I combine these 2 points, the incumbent would never choose to produce a capacity, choose to set a capacity which is less than M1. Now, with this in mind, let us look at what are the possible scenarios for K1 that might arise. Okay, so, let us Let us look at multiple cases. So let B denote the point, let the point B denote the point, B denote the point on the entrance best response function, on the entrance best response function at which pi 2 is equal to 0. So, we will be drawing these graphs again and again so as to not clutter them. So, let us graph it properly now. So, we have Q1, we have Q2, and we have firm 2's best response curve BR2. So, this is T, this is V. So, let us say B is a point, let us say B is a point like BL, right. So, B is a point like BL, right. So, in other words, suppose, so this is case 1, suppose B is a point like BL where the profit is going to be where firm 2's profit has become 0. So, essentially it tells us that firm 2's profit at T1 T2 is strictly less than 0. So, this is T1 and this is T2. So, this is T1, this is T2, this is my monopoly output M1, which is also the Stackelberg output S, right. So, it turns out that suppose the fixed cost or the market conditions are such that firm 2's profit at BL is strictly less than 0, is equal to 0, and more importantly pi 2 at its most favorable Nash equilibrium for firm 2 is less than 0. This corresponds to the case of what is called blockaded entry. This corresponds to the case of what is called blockaded entry. So, entry by E is never profitable. So, entry by E is never profitable. So, entry by the entrant is never profitable. So, the incumbent, so entry by E is never profitable. So, the incumbent will choose capacity M1. So, the incumbent is going to essentially choose a capacity which is equal to M1. The second case is where B is a point, let us say B is a point like BS, B is a point like BS where again pi 2 where the entrant is going to break even at T. B is a point like BS where the entrant is going to break even at T, but so let us call this to be M2, but its profit at M2 is less than 0. In such a case again the incumbent will choose to produce the monopoly level of output, right. So, even in this case I will choose the monopoly level of output M1, right. So, suppose we have a case where the B is at BL or at BS, here the entrant breaks even at T2, but at M2 it is negative, the incumbent will still find it profitable to choose the monopoly level of output at M1. Let us look at a third case now. Let us look at a third case now, and this is again T and V, right. So, we have and this is the monopoly level of output M1, which is also the Stackelberg level of output, which is S, right. So, now let us say that B is equal to BH, which is to the right of V. So, B is equal to BH, which is to the right of V. We will see this again separately, but let us just get the intuition. So, now the entrant's profit is positive at its worst possible Nash equilibrium. So, in such a case the incumbent will find it simply profitable to accommodate the entrant and not deter it. So, this is the case where entry is accommodated. Okay. So, we have looked at a case where the B is equal to BL and it is equal to BS, where the incumbent will simply produce the monopoly level of output, and now we have a scenario where deterrence becomes extremely costly. So, the incumbent will want to accommodate entry. We will revisit this again. Thank you.